Okay, sometimes when you're trying to do division with rational expressions, you can't, the numbers aren't going to come out even. Like that top number is not going to be very factorable, so you can't factor and cancel. I apologize that they have this a little misaligned. I sent a message off, and I think they have it right online. So I think that goes like this. Yeah, there we go. We're good. No, oh, it's fixed. All right, they fixed it. All right, it was wrong online. Anyway, so I'm going to talk you through how they do this area model business. You can also do this with synthetic division, but or long division, I think they call it. And moral of the story is no kids from Dover Yoda have had much luck because nobody remembered how to do long division. So I use the box method. But you know, if you're using long division, you can probably look at this and it's all the exact same stuff. So I'm going to split the screen here and give you guys a rundown of how to complete that box. So we're going to start out with a box that has two rows, and basically we're going to wind up trying to take the denominator and put it along the left side, and we want to figure out what's going to have to go in up here for these other dimensions so that everything inside the box winds up adding up to x to the fourth minus 6x cubed plus 18x. Ooh, back up, plus 0x squared plus 18x minus 1. All right, so you write that numerator across the bottom. And what's supposed to wind up happening is that's what these arrows are all about. So this is going to be x to the fourth. Whatever comes in these two boxes, so see I don't have it aligned very well, should be negative 6x cubed, and so forth and so on. So I'm going to fill x to the fourth into this space here. And if that's an x to the fourth, then the top part is going to have to be an x cubed. So if that's x cubed, which makes this a negative 2x cubed. And here's where we have to get a little bit, creative in that these two numbers, whatever is in these two boxes, okay, this one and this one have to add up to negative 6x squared. So if that's a negative 3x cubed, I'm sorry, negative 3x cubed, then this space is going to have to be a negative 4x cubed in order to add up to negative 6x cubed. And now we can keep on playing the game. If the left side is x and this is negative 4x cubed for an area, the top is going to have to be negative 4x squared. If that's negative 4x squared, that's negative 4x squared. So if I multiply here, I'm going to wind up with 8x squared. And here's that deal again. Whatever goes on in these two boxes, okay, this one and this one, has to add up to a 0x squared. That's what these things are talking about right here. And so if that's an 8x squared and I want that to be a 0x squared, grand total, then I'm going to have to make this a negative 8x squared in order to get it to add up to 0. All right, and then we keep going on. If the left side's x and the area is negative 8x squared, the top is going to have to be negative 8x. And if the top is negative 8x, so is the bottom. And negative 8x times negative 2 is going to be 16x. And I left my box kind of an undecided length because I didn't know where it was going to end. And I still don't think I'm to the end, or I'm getting close. All right, so whatever is in these two boxes has to add up to, and see I don't have my arrows right, has to add up to 18x. That's this piece right here. Well, so that means we're going to have that 2x in this space. Thought that would be red. That'll have to be 2x. And then we keep going on down the line that that's x, The area is 2x, so that means the top is going to have to be a 2. And so the bottom's going to have to be a negative 4, but I only have a negative 1. So everything that's in the box has to add up to everything that came out to be down here. So that means I only needed a negative 1, but I have a negative 4, so I'm going to have a remainder of negative 3. And I don't put that in the box per se over here on the right-hand side. I just kind of leave it dangle out there because it's a remainder. Because there's no way that x is going to go into negative 3. So the final answer turns out to be what they have here, that this negative 3 was not able to be divided by x plus 2. It still needs to be divided by x minus 2. I'm sorry, x minus 2. That x minus 2 has not divided in there yet. So that's why the final answer is x cubed minus, I'm pulling this off the top, x cubed minus 4x squared minus 8x plus 2, and then I still have yet to take this negative 3 and divide it by x minus 2. This was called Polyduco in our last book, and it was a section that we opted to skip. It just occurred to me also that maybe people don't understand why it is that that is supposed to be this fraction over on the end. So I thought I would kind of do a more concrete example and see if we couldn't explain that a little bit better. So if I took something like 11 divided by 4, well, I'm going to have 1, 2, 3, 4 grand total along the side, and I would wind up having a 4 by 2, which makes a total of 8. But that means I have 3 total that have yet to be divided by 4. So that is 8. There's, sorry, that winds up being 2 and 3/4 because I had these 3 that haven't yet been divided by 4.